preparing for this presentation was quite challenging. We didn't know what we were going to talk about. Of course, we were going to talk about science, but everybody wanted a piece of their personality. For me, this meant trying to do something unexpected and silly. But the idea of telling a joke on stage and nobody laughing was frightening. So the weeks passed, and I saw my friends writing their amazing stories. So I got a little nervous. Until one of these days, while I was staring at the computer, I found something that I think it was interesting enough for this presentation. It was something that I really enjoyed as a kid, and something that I started to appreciate even more after my master's in mathematics. And that thing is broccoli. I advocate for broccoli as the best vegetable out there. It has an interesting texture, a healthy green color, as opposed to the cauliflower. The taste is amazing, and in Brazil, where I'm from, this type of broccoli is called ninja broccoli, so even the name is cool. But of course, I'm not talking about broccoli today because of this. Like any other kid, I used to play with my food, and broccoli was no exception. I would take a piece of broccoli, I would cut the stem, and I would end up with a smaller piece of broccoli. To my mom's despair, I would repeat this until my plate was covered in these small tree-shaped vegetables. I didn't know this at the time, but shapes like this that you can cut and you end up with a smaller version is what mathematicians call fractals. Historically speaking, the idea of fractals is very old, but the first person to use this term was Benoit Mandelbrot in 1975. For him, shapes in nature were complex, so normal geometry couldn't handle it. In his own words, clouds are not spheres, mountains are not cones, nor does the lightning travel in a straight line. Not only the shapes in nature were not simple, they were super complex. As an example, in 1951, the mathematician and pacifist Louis Richardson was studying the causes of war and how to prevent them. And while he was studying how the length of the border could affect the probability of war happening, he stumbled across something strange. Portugal reported their border with Spain as 789 kilometers, while Spain reported their border with Portugal as 1,214 kilometers. This is almost a 25% difference. Richardson realized that the problem was in the scales that geographers use. For most things, using a smaller scale meant a better measurement. So for instance, if you want to measure my height using only meters, you would get 2 meters. But if you are also allowed to use centimeters, you would get 168. It's a much better measurement. But for the border of countries, this was not the case. As you use smaller scales, the length of the border would go to infinity. Sometime later, Mandelbrot came across Richardson's problem, and he wrote a paper to propose a solution. For him, it was simple. Geographers just need to agree on a scale. But he also knew that people were stubborn. So instead of dealing with them, he decided to invent a whole new era of mathematics, where shapes like squares and triangles would have dimension 2, and shapes like the border of Spain and Portugal would have dimension 1.28. Mathematicians later also came to realize that fractals were quite common in mathematics. We mathematicians are well acquainted with counter sets, Sierpinski triangles, and Weierstrass functions. And I have to be honest and say that I hated fractals for a long time. I just couldn't understand the feel of it. The Mandelbrot set, that's the most famous one, just looked like a blob of oil in a pot of water. It's just ugly. But as kids grow up to like vegetables, I also grew up to like fractals. Right before I started my master's, I came across what's formerly known as iterated function systems, but has a much more appealing name, the chaos set. And I cannot tell everything about it in a 7-minute talk, but what I can tell you is that it's a way of constructing fractals using probability. and everything that comes from an area of mathematics that evolved from gambling has to be fun. So much fun that I spent my last 2 years studying for my master's. And now, of course, it's a lie when I tell you that finishing my master's in mathematics made me appreciate broccoli even more. And while the relationship between me playing with my food as a kid and me pursuing a master's in mathematics is at least questionable, I hope that me playing with my food today at least sparks a little of curiosity inside of you. Thank you very much.